So we're going to start this project off today. It's called the Geneva mechanism. It is a little device that basically turns constant rotational motion into intermittent linear motion or intermittent radial motion. So as this rotates around, it basically hits the slot in this drive wheel and it rotates at 90 degrees and it indexes it basically. So it's kind of similar to what a tool changer looks like. You may have a drive motor here that is constantly rotating this area here, but if you want intermittent start-stop motion, depending on what the number of slots are here, you can get 15-degree motion. This right here is 90 degrees, right? There's 4 positions here: 90, 80, 270, 360. So we're going to start really simple this semester with the base plate. Okay, so the base plate looks like this. It's a simple rectangular shape. Dimensions are not important at all, basically, except for the hole positions here. And we're going to start off by building a Solidworks assembly with solid stock and with a set of parallels, so that we can machine, we can face the top of the part and then drill the holes. Again, to keep it simple, we're only going to face the top of the part, and we're just going to talk about how we would normally start a project like this or a part like this. So the very first thing I want you to do is to, you download those files, you open up the blueprint, you want to decide what your stock size is going to be. Okay, now looking at these dimensions, again, we have a one place 6.0 and a one place 4.0. That basically tells you that the outside dimensions of this plate are not very important. Okay, we also have the same thing, one place decimal, ½ inch down the bottom here. If you had 3 place decimals on all of these on all these dimensions, you may have to decide to actually machine the entire outside profile. That's obviously going to affect your stock size. Okay, we'll spend more time talking about that in class. Well, a lot of time talking about that in class too. Today, what I would like you to do is to create a solid stock profile that's going to be 6 inches by 4 inches by 3/4 inch thick. So we're gonna face 1/4 inch off the plate, and again, we're just doing that to kind of practice. It's not really something that we may do in real life, but it's just an easy way to deal with this, an easy way to start building our knowledge base of SolidWorks. So you're going to want to keep this print handy. Obviously, I'm not going to be able to show it on the screen the entire time, but so this is the print you're going to want to follow for now. Now, when you open SolidWorks, the very first thing it's going to ask you for is it's going to show you this screen here. It's going to be a new part. If we're creating a piece of solid stock, it's going to be a part. Okay, I'm going to click OK, and I'm going to go through all of the drawing steps. Okay, you don't have to be super proficient in SolidWorks to do this course, but you do need to have some basic knowledge of it. Okay, so we're going to walk through creating a solid block for our stock, and then we'll use that in our assembly later on. I'm going to start by going to the Sketch tab on the upper left hand corner. I'm going to click on Sketch. In this case, I'm going to start drawing the part from the top down. We know we want a 6x4 rectangle. I'm going to select my top plane, and we're going to enter into the sketch mode. Now, after entering sketch, it's a simple rectangle, so I'm going to go up to the top left hand corner. I'm going to use the command called corner rectangle. I'm going to left click on that. I'm going to anchor the bottom left hand corner of my rectangle at 0, 0 here. You see it snaps. I'm going to left click once, and I'm going to expand my rectangle out. I'm going to left click again. After you left click, you'll see that we have a highlighted box here. It's showing that it is a closed chain. I'm going to click OK in the rectangle command, and now we're going to dimension this. The Smart Dimension icon is right up next to the corner rectangle button. I'm going to hit Smart Dimension. I'm going to first dimension the top line. That's going to be our 6 inches. Again, I'm using left clicks to select the line and left clicks to drop the dimension. I'm going to type in 6 inches and click on the green checkbox. And then I'm also going to dimension the vertical line. This is going to be 4 inches. So I'm going to left click that vertical line, left click on the dimension, and then put 4 inches there and hit the green checkbox. It doesn't matter where these dimensions are, you can drop them anywhere you want to. Ultimately, what you want to see is black lines. That means the feature is fully constrained and everything is locked in place. So if you see any blue lines on any of your stuff when you're working, that means you need more dimensions to constrain the overall drawing. After we have 6 and 4, we're going to exit the sketch. The dimensions and everything go away, but that's perfectly normal. That's not a big deal. I'm going to exit the Sketch tab and go to Features. And we're going to extrude this rectangle by a certain distance. So again, we preliminarily decided that we're going to have a 3/4 thick plate that we're going to face a 1/4 inch off of. So over in the left hand side where it says D1, we're going to go ahead and put 0.75. I'm going to hit enter. And in this case, it doesn't matter which direction we go, and we can go up or down. Just want to make sure it's 0.75. That's what we want. So in this case, I'll just let it go down. That's perfect. I'm going to click OK. And we are done. So this is a solid piece of stock that we're going to use later. It might be a good idea to change the color just so that we know it's a different, it's easier to identify when we go into the assembly. In order to change the color of this block, I am going to go over to the right hand side, and there's an Appearance, Scenes, and Decals button, which is like a ball that has different colors on it. I'm going to left click on that. I'm going to go to Appearance, Color. I'm going to double click on Color, and I think I can just drag this right over to the part. Select Body. I haven't done this in a while, sorry, bear with me. I basically just want to change the color here. Maybe we'll just do it this way. So you see up here by Appearances, we'll use the drop down. We'll go to Painted. No, I don't like that. Let's go to Plastic. No, I don't like that either. I basically just want to click on the color here. I don't know why it's being a pain in the butt. Maybe it's easier if we just go up to Edit Appearance. Let's see what that does. Ah, there's the color wheel that I was looking for. So we have Edit Appearance. Let me show you that again. Well, let me walk through it first. We'll do this. I'm going to make my stock green if I can. That's all good. Click OK. No, that didn't work. Let me investigate this real quick. I'll be right back. 1 second. Okay, I decided on the best way to show you this. So, in order to change the color of the stock block, I'm going to go over to where it says Boss Extrude, and that is the command that we just ran. If you left click on Boss Extrude, that gives us the option to change the appearance right here. So I'm going to left click on Appearances, and I'm going to select the topmost item on the tree that says Boss Extrude. We don't want to do individual bodies or anything. We just want to do the whole thing. So I'm going to left click on Boss Extrude, and then at that point we can just come down here and change the color to anything we want. So in my case, I'll do like a nice lavender or something like that. You can pick whatever color you want as long as it's not red. Okay, for the same reason as last semester, because red is used for crashes, so we don't want to use red. So we pick a nice color. I'm going to click OK. Perfect. Now, while I'm here, I'm also going to right click on this, and I'm going to change the transparency to see-through if I can do it here. Or I may have to go, actually may have to go up here and do it. Basically, later on down the road, we're going to want to be able to see through this. Maybe we'll just do it in the assembly for now. So I've changed the color. This part is done. We're going to go ahead and save this. Now, this is where file structure is important. I'm going to do File, Save As. I'm going to go and find the folder that I'm working in. So for you, it should be that week 1 folder that you created, basically off that prior video that you just watched before. In my case, here's my week 1 Geneva mechanism plate. I already have the 2 solid parts in here for the jaw. There are more files in here, right? But because this is being filtered by parts, it's not showing everything. It's only showing me the parts for now. So I'm going to save this, and as far as the name structure goes, I want to start with the operation number. So in this case it'd be op10, and I'll do underscore solid stock. So in some instances you may have more than one operation, which means you may have more than one Solidworks assembly to deal with. If that's the case, you want to make sure you have op10 specified in the save name for your stock. So after we have that, I'm going to click on save, and this piece of stock is done. So that's perfect. I'm going to close this, and now I'm going to go ahead and open the Solidworks assembly just so I can show you the vise, and then we're going to discuss another piece of fixturing that we need to create before we actually begin to assemble. In order to open the file, I'm going to go up to File and Open. And inside of the week 1 folder, again, you should have a Kurt vise. It's named Simple Kurt vise, unless you renamed it. You can rename it if you want to, but you got to relink these things, which we'll talk about later. So for now, we're just going to do Simple Kurt vise. Okay. I'm going to select the solid assembly, which is SLD-ASM, and I'm going to click Open. We're going to let this load up. Sometimes it takes a couple of minutes for it to get loaded and ready. Perfect. So inside of the assembly there are 2 solid parts. There's a fixed main body, and then there's a movable jaw. Okay. Now I have this set up in advance so that you can actually adjust the jaw and move it from back and forth, but you will see that I have it locked from left to right. So it's only, right now it's only free range of motion is this direction here. Now, what we're looking for next, okay, we can't just put pieces in here floating because we don't really have any way to prove that it is sitting flush, right? You need to have these sitting on something. The tooling that we're going to be using is called, it's called a parallel. It's basically a ground precisioned rectangular block that we place underneath our stock before machining, and that allows us to tap it down and square it all up in all directions. So the jaws here are parallel, and then the parallels that are actually underneath this will allow the part to sit flat and flush, so that when we go to face, we're going to make a nice straight and flat cut. The one thing you need to pay attention to is the height of your parallels. Okay, that's going to be variable. So depending on the thickness of your stock and how much you have to hold in the vise, you're going to have to adjust the height of your parallels. So as you actually draw these out, you're probably going to end up having more than one set. Okay, really simple to adjust. We're going to make a set right now, and I'm actually going to put them in a separate folder so that I can take them out and use them in any week that I want later. I don't want this just to be a specific to week 1 thing. First thing I want to point out is how to measure in Solidworks, in case you're not familiar. So in order for us to make our parallels, we got to check a few things. I'm going to go to Evaluate, the Evaluate tab, and up here is a measure. It looks like a measuring tape. The first thing I want to check is the width of this, because I'm going to make my parallels match the width. I already know what it is, but I want you to know how to check it. So I left clicked on measure. I'm going to click on the first face, and I'm going to click on the face that I want to measure in between, so the opposite side. Perfect. So you see we have a distance of 6 inches. So the parallels that we draw are going to be 6 inches long. Okay. The next thing that we want to look at is what's the depth of our Kurt vise, right? How deep is this? So if we do a measurement from the bottom of the vise to the top of the jaw, we get a dimension of 1.74. And you may even want to jot this stuff down at some point just to see, just so you know what we're dealing with. So looking at 1.74, okay, that means our parallel height can't be greater than that because you need to have some kind of work holding here. But you also need to make sure that it's high enough so that the part is sticking out when we're facing it. So in this case, if we do a 1.5 inch parallel and then we add a 1/2 inch to that, which is the final part width, that means we'd have a 2 inch height from here to the top of the part, which would give us enough stick out. It should look pretty good. So in our case, I'm going to do 1.5 inches, and we will draw that right now. And as I said, we'll save that in a separate folder so that we can use it later on down the road. We only need to draw one parallel for now, and then we're going to insert 2 into the assembly when we're done. I'm going to leave this alone for now. I'm going to go ahead and do File, New. I'm going to do a new part. And we are basically just going to do the same exact thing we did before with the stock. We're just going to make a parallel instead this time. So we're going to go to Sketch. I'm going to click on Sketch. We're going to left click on the top plane again. I'm going to select rectangle or corner rectangle. I'm going to snap to 0, 0. Just let it go over there like a O snap. Left click there, expand it, left click out to the corner, and I'm going to click done, corner rectangle there. So now we need to dimension it based off of what we just learned in the SolidWorks assembly we're looking at. So I'm going to go and left click on Smart Dimension. I'm going to select the horizontal line first. This is going to be our 6 inches. That's going to match up with the edge of the curved vise. And then this is going to be variable depending on your project. So again, we're going to try 1.5 inches first. And this is our first parallel. Okay, so dimensions 1.5 by 6. I'm going to exit the sketch. And then these parallel, I haven't mentioned it yet, but they tend to be skinny because you don't want them to interfere with drill throughs and milling operations. So generally they're 1/8 of an inch thick to 1/4 of an inch thick. For our case, I'm going to go to Features and Extruded Base, and we're going to go with an 1/8 inch thickness. So that's 0.125. Hit enter. There's the preview. After that, I'm going to click OK. So now I'm also going to change the appearance on this too. So I'm going to left click on the extrusion. I'm going to go to Appearances. I'm going to click on Boss Extrude 1. And I'll change this color to a green, something like that. Again, you can pick whatever color you'd like. So I'm going to click OK. And now our parallel is complete. Sometimes you'll see holes drilled through these, things like that. I'm not worried about making it fancy. This is all we need. Now again, I'm going to do a File, Save As. And this time I'm going to do something a little bit different. Okay, so since this 1.5 inch parallel may be copied and moved into different weeks, I don't want it to live in the week 1 folder. So I'm actually going to go back to my Cam2 folder, and I have a file called Fixturing Files that has all my base fixturing stuff in it. I'm going to go in there and save this part in there. So the reason being is because, like I said, I may copy this out later and use it in a separate week. So I don't want to just leave it in the week 1 folder. So I'm going to have 1.5 inch parallel. I think it's spelled L-E-L, parallel. I'll have to check. So I'm going to save that. Now I'm going to close my parallel now that I've saved it. Now we're looking at my solid assembly again. So Just to be clear, so we saved the parallel in a separate folder, okay, in a fixturing files folder. I'm now going to copy it and paste it into week 1 because I am going to use it in this week. But again, I don't want to just go into the fixture here. I don't want to just go into here and use this file. I want to copy it and move it, because if I ever modify this file here, it'll modify it for every file you use it on. So I want to try and isolate it basically. So now I've placed my 1.5 inch parallel inside of my week 1 folder. And you're starting to notice now this folder is starting to get pretty big, right? That's going to happen, all right? But as long as you keep everything in the same folder, you're okay. It does not matter as long as it's all living in that one folder. So we are going to now start talking about putting constraints in an assembly. So we're going to start by building out and putting the parallels in place. Okay. Again, you don't need to be a master SolidWorks user to do this, but you do need to practice with it. Okay. It does take some getting used to if you haven't used it before. To start, we need to import the parallel that we're going to be placing into the vise. I'm going to go to the Assembly tab. I'm going to go to Insert Components, and I'm going to do the Insert Component there. Okay. Now you'll notice that it opens up, right? It's pointing at the wrong folder right now. You want to make sure we get the right file, so I'm going to back out. I'm going to find my week 1 folder that's got everything in it, and I want to grab my parallel out of that. So I'm going to hit open. Now you'll see that it's attached to my mouse right now. Okay, you can drop more than one if you want to. So in this case we want more than one. So I'm going to click twice. I clicked once. Oh, actually there must be a separate way to. It used to let you do it twice. I want to insert. I'm going to put 2 of these in at once. I'm going to go back to Insert Component. I'm going to select the parallel again. And where does it say? Somewhere in here it should allow you to do multiple components. That's alright. So I'm dropping my second one in, and now I have 2. So our parallels are going to go and be attached to the 2 edges of the curved vise here. I'm going to start by constraining the bottom of the parallel to the bottom of the vise. And the way we're going to do that is we're going to use mates. So up next to Insert Components, the mate button, it has a paperclip for an icon. So I'm going to left click on that mate icon. And this is the mating substructure that we're going to look at. As you select surfaces, it's going to default to certain standard mates. Most of the time they're going to be correct and you won't have to mess with them, so that's always nice. But you do want to make sure that it's doing what you expect it to do. So in order to mate 2 surfaces, you have to obviously select them both. I'm going to start by selecting the bottom edge of one of these parallels with a left click, and then I'm going to select the bottom part of the vise. Now you're going to see the orientation changes. That's exactly what we want, so that's perfect. I'm going to click on the OK box there. And now we're going to move on to our second constraint. I'm going to pick the side of the parallel and the side of the vise. You see it moves to be an aligned coincident mate. That's perfect. I'm going to click OK again. Now I'm going to attach this side of the parallel to this side of the vise. So I'm going to select that, and we're in good shape. I'm going to click OK. And now to double check and make sure that I've removed all the degrees of freedom on the parallel, I'm going to left click and try to drag it around. You'll see that it's attached to the movable vise jaw, but it is not moving independently, and that's exactly what we want. We'll lock the entire jaw down later on when we're putting the other materials in. So now we're going to do the same thing for this parallel. I'm going to go back into mate. I'm going to start with the bottom of the parallel again. I'm going to select the bottom of the vise, Click OK. I'm going to select the outer edge of the parallel, the outer edge of the vise. Click OK. And then I'm going to rotate the mouse around with the center wheel until I can get a good pick here. I want to get the inside edge of the parallel there, and then that area there too. Perfect. So that's one thing I may not have mentioned. So in order to rotate the part in space, you hold the middle mouse button down and you're able to rotate everything around. So that is all we need for fixturing. So the parallels look good. I'm going to go ahead and save the assembly. And now we're going to, if it does ask you to rebuild the document, that's fine. Go ahead and rebuild and save. It's basically looking at the links between the files again. I'm going to save it one more time just for good measure. Now, we're going to insert our part and our stock coming up next here. So I'm just going to grab a drink. I'll be right back. So we are now going to bring in the next two parts that we need for our assembly, one of which being the stock that we just created earlier in the video, and the second is the actual part model for the manufactured part. I'm going to go to Insert Components. I'm going to first bring in the part model, so P0101-003. I'm going to left click and drop that anywhere in space for now. Not concerned where it is at the moment. I'm going to go back to Insert Components, and this time I'm going to select the Op10 solid stock that we created earlier. And again, same deal, I'm just going to drop that in space anywhere. So what we're going to be doing is actually constraining the part inside of the stock block. This is where remembering what your machining strategy is going to be is important. So we're not going to machine the bottom. We're only going to face the top and drill the holes, which means all of the outside edges are all going to be equal. The bottom is going to be equal, and then the top is just going to be bigger on the stock block. So we're going to go to Mate, and we'll start by mating the two bottom surfaces of these solids. Then I'm going to pick the two 6-inch links of these. Now if your mate is opposite, this is a good example of how you switch it. So the mate alignment, Mastercam is assuming anti-aligned, and we actually want the other one aligned. So we're going to click on that to switch it over. You see that looks good there. Now some cases you may have to actually exit the mating command and pull the parts apart in order to get at the surface you want. So I want to click on this edge and this edge. So if it's buried in there, it's hard to get. So we can move that, go back into Mate, and now I'm going to go ahead and grab that edge and lock those in place. So now you'll see that the actual machine block is mated inside of the stock block. The whole assembly by itself is not constrained to the vise yet, but the individual parts themselves cannot be moved or separated. Now in order to help facilitate and see what we're working with down here in the vise, I'm going to make the stock block transparent. And the way we can do that here is by selecting the top of the stock block, and then there is a change transparency button, which is basically has an eye in the bottom left hand corner and it looks translucent. I'm going to click on that, and then we can actually see the part inside of that. Makes it nice to look at. So now we're going to constrain this whole subassembly into the Kurt vise. I'm going to start by constraining the bottom of the subassembly to the parallels. I'm going to click on that. I'm going to click on top of the parallel. Either one is fine, doesn't matter which one. So that's good. Now I'm going to pick an outside surface here on the 4-inch side, and I'm going to align it to the side of the vise here. This should flip it around. Again, check your mate alignment. So this is opposite what we want. So I'm going to go ahead and switch the mate alignment. I'm going to click OK on that one. And now the final degree of freedom is going to be locked in place on the fixed jaw. So we're going to lock the fixed jaw to the back part of the part here, and then we'll lock this to it later. So I'm going to bring this 6-inch surface to the fixed jaw, which is the surface right here. Going to click OK. And before I do anything else, I'm just going to confirm my heights. Okay, so we have a good amount of material inside the jaws here, about 1/4 of an inch. That's perfect. We have clearance. We're going to be facing up to here, so we have plenty of clearance. We're not going to hit the vise. And we also have enough throw in the vise to actually grip the part accurately. So we want to lock this in place next, so you can kind of guess where we're going to go with this. I'm going to take this fixed, or the movable jaw. I'm going to click on the surface there, and I'm going to lock that in place to this part of the vise here, or this part of the part that we built. I'm going to click OK. And now I'm going to try to basically click and drag and move anything. At this point, everything should be locked in place and nothing should move. And this is exactly what we want. So for Solidworks, this is complete. We've just completed the setup. We have a very accurate model setup. It looks exactly the way it would look if it was in the machine. I'm going to go ahead and save this file. And at this point, we are ready to actually import this into Mastercam and set that up for our machining operations. So we'll be doing that in the next video. I'm going to go ahead and stop this one for now and then start a new one. This one's going, it's 30 minutes already, so make sure you save your work. And when you are ready to move on to the Mastercam import and setup, you can go ahead and check the next video out. Thanks.